Is a 4-layer PCB always cheaper than a 6-layer PCB? On paper, the answer is yes. But in real-world projects, choosing a 4-layer PCB can sometimes be the very decision that increases the overall product cost. That's because the real cost is not just the bare PCB manufacturing price. Real cost includes PCB size, failed tests, EMI issues, additional filtering components, shielding, heatsinks, redesigns, production delays, and even product failures during final testing. In this video, we'll examine when a 4-layer PCB is the more economical choice, when a 6-layer PCB makes more sense, and how selecting the wrong layer count can put unnecessary pressure on your project budget. As projects become larger and more complex, designers and project managers face one of the most challenging economic decisions in PCB design: choosing between a 4-layer and a 6-layer PCB. At first glance, the calculation seems simple. Due to additional manufacturing steps, higher material consumption, and a more complex lamination process, the base cost of a 6-layer PCB is typically about 30 to 50% higher than that of a 4-layer PCB. However, if you think choosing a 4-layer board always saves money, think again. In many modern projects, especially those involving high component density, high-speed signals, RF circuits, sensitive power supplies, or strict mechanical size constraints, a 6-layer PCB can actually reduce the total project cost. Looking only at the raw PCB fabrication cost can be very misleading. In high-density designs, when you try to force all routing into just 4 layers, one of two things usually happens. Either you increase the overall board dimensions, which raises enclosure and mechanical costs, or you end up using more expensive technologies such as blind and buried vias. By moving to a 6-layer PCB, the 2 additional internal layers provide greater routing flexibility, allowing for a more compact layout, a smaller PCB footprint, and ultimately a better, balanced total system cost. So how do you design a 6-layer PCB without driving costs through the roof? The key is a smart stack-up design. To optimize cost, use standard through-hole vias whenever possible and avoid complex HDI structures and laser-drilled microvias, unless they are truly necessary. In addition, layer geometry and thickness should be configured so that controlled impedance, for example, on high-speed USB, DDR, or other high-frequency signal lines, can be achieved without requiring extremely tight manufacturing tolerances. Following this principle can prevent sudden increases in fabrication costs. However, the greatest advantage of a 6-layer PCB becomes apparent when dealing with EMI/EMC challenges and thermal management. At high frequencies, a 4-layer PCB that is not carefully designed can generate significant noise. To pass commercial compliance standards, you may end up adding expensive filtering components, metal shielding, large heat sinks, or even making major design revisions. With a 6-layer PCB, continuous ground planes can be placed adjacent to signal layers. This creates shorter and more controlled return current paths, reduces noise, improves heat distribution, and lowers the risk of failing early stage testing. So what's the final takeaway? A 4-layer PCB is not always the cheaper option. If your design is simple, low density, and operates at relatively low speeds, a 4-layer board may be the best choice. But if your project involves space constraints, high-speed signals, noise concerns, EMI requirements, thermal challenges, or high component density, investing in a 6-layer PCB can help avoid much larger costs later in the development cycle. In PCB design, the right question is not which board is cheaper to manufacture. The right question is which choice minimizes the total product cost. If you're unsure whether to choose a 4-layer or 6-layer PCB, send your design files, stack-up information, or project requirements to the High PCB team. Our engineers will review the DFM considerations, layer structure, and manufacturing risks to help you make the best technical and economic decision before production begins. For a free preliminary review, contact us through the link in the description below. If you found this video helpful, please like, subscribe, and let us know in the comments. In your projects, do you use 4-layer PCBs more often or 6-layer PCBs? See you in the next video.